go over some basic partial fraction decomposition. So what is partial fraction decomposition? Well, let's look at an example here. Let's say I wanted to combine the fractions 2x over 5 plus 3 over y. How would I combine this? Well, I would need a common denominator. So let's multiply both sides in order to get a common denominator. So let's multiply this by y and then multiply this by 5. Then I would get 2xy over 5y plus 15 over 5y. And then since we have a common denominator, we can just add these together. So we get 2xy plus 15 over 5y. So this is kind of the basic idea of partial fractional decomposition, except we'd go the other way around. We'd turn this back into this. So how do we do this? Well, let's look at a quadratic denominator example. Let's say we had 2x plus 3 over x squared plus x minus 2. So here we have a quadratic denominator. So when you have a denominator that's a quadratic, we want to factor this out. So to factor this out, it would be x minus 1 times x plus 2, and we know that this is true because if we do 2 minus 1, then we get the middle term here. So let's just replace this with this. So we would have 2x plus 3 over x minus 1 times x plus 2. Now, when we're setting up a partial fraction, it looks something like this. It'd be equal to a over x minus 1, which is the first part, plus b over x plus 2. Now our challenge is we have to find out what is a and what is b. So let's multiply both sides by this denominator to just cancel it out. So we multiply both sides by x minus 1 and x plus 2. So this cancels out. So we get 2x is equal to, so this and this cancel out, so it'd be a times x plus 2 plus, since this cancels out, it'd be b times x minus 1. Now let's expand this. So we get 2x is equal to ax plus 2a plus bx minus b. Oops, sorry, I forgot the plus 3. So we can notice on the left side of the equation here, we have x. So what do we factor out in x to make this a bit easier? So we have 2x plus 3 is equal to x. Since there's an x here and x here, we do a plus b. And then let's just leave these out here. Now, what can we notice about both sides of the equation here? Well, we notice that there's a 2x here, and there's an x times a plus b. Now, what does this mean? Well, that means that this, since this is the only x present on the right side of the equation, a plus b has to be equal to 2, because look at the coefficient here. So what does that also similarly tell us about 2a minus b? Well, it also tells us that 2a minus b is equal to 3. So we can simplify this to 2a minus b is equal to 3. And look, we have a systems of equation. We have two equations and we have two variables. So let's just add these two equations. So this would cancel out, so we get 3a is equal to 5. If we divide both sides by 3, we get a is equal to 5/3. Let's substitute it into the first equation here. We'd get 5/3 plus b is equal to 2, meaning that b is equal to 1/3. So look, we found our a and b. So we can just plug it back in to our equation here, and we would have fractionally decomposed it. So it would be 5/3 over x minus 1 plus 1/3 x plus 2. Now, when we have fractions on the numerators, in order to simplify this, we know that it's just equal to if we just multiplied it by the reciprocals. So let's just simplify this. This would be 5/3 times 1 over x minus 1 plus, so let's do this side now, 1/3 times 1 over x plus 2, which would be 5 over 3x minus 3 plus 1 over 3x plus 6. So here we would have fractionally decomposed an equation. Now let's see where we can use this in problems. Let's say we were asked to find the sum of the following sequence: 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, all the way until 1 over 99 times 100. We can actually use what we just learned to apply it to these kind of equations. So how can we do that? Well, let's just write this into a fraction. What can we notice? Let's say this number is just equal to n. So this would be 1 over n times n plus 1, because 2 is 1 greater than 1. So let's set up our fraction. We get a over n plus b over n plus 1. Now our challenge is, how do we find a and b? Well, we just do what we just did. We multiply both sides by n times n plus 1. 1 is equal to a, since this cancels out, would be a times n plus 1, plus b times, since this cancels out, just b times n. Okay, now let's simplify this. Let's expand this out, and we would get 1 is equal to an plus a plus bn. So we have a constant term n here. So when we have a constant term n, let's just factor it out. We get 1 is equal to n times a plus b plus a. So with this, we need to figure out what a and b are equal to. The expression on the right has basically two parts. We have this part and this part. This a is a constant. And if we notice here, this side of the equation doesn't have n whatsoever. So what does that mean? On the left side, there's no n. The coefficient of n would just be equal to 0 if it was here. So what does that tell us about this? Well, it tells us that this thing would just be equal to 0 because it's not present on the left side in order for it to be equal to 1. So on the left side, the constant is just 1, just similarly to this. On the right side, the constant is a. And since n isn't present on the left side, we can determine that a is just equal to 1. Okay, well, if a is equal to 1, what does that tell us about b? Well, if I substituted this back in, I'd get n times 1 plus b plus 1, which would tell us that b would just be equal to negative 1. So we determined that b is equal to negative 1. Okay, well, let's substitute this back in. So if we go back to this original equation that we made, then we'd get that 1 over n times n plus 1 is equal to 1 over n plus negative 1 over n plus 1. So with this, let's try to solve the original problem we were given. So if we know that this can be written as 1 over n minus 1 over n plus 1, let's just write this out a bit. We do 1 over 1 minus 1 half plus 1 half minus 1/3, so on, so on. So if we noticed here, with this equation that we got, we can just completely cancel out these terms, because negative 1/2 plus 1/2 is just equal to 0, and this will go on forever. So what do we get? So most of these terms cancel out. The only term that we're not going to cancel out are these terms. So then we would get 1 over 1 minus 1 over 100, because these are the first and last terms which aren't going to get subtracted off. So then we would get 100 over 100 minus 1 over 100, which would just be equal to 99 over 100. So this is an example of a question where we would use fractional decomposition, where we have an expression and that we want to simplify it more.